Hello, in this short video, I'm going to talk about location cost volume analysis. This is a very simple method. So let's say that you have multiple locations that you can choose from. So what is the right location, right? In the location cost volume analysis, we think about the cost as a two category. One is the fixed cost, and the other is the variable cost. And using cost volume analysis and help us to compare the total cost given the sales volume. Okay, and this is an economic comparison of location alternatives. And there are three steps in this method. First is determine the fixed and variable cost for each location. Then plot the cost for each location, and then select the location with the lowest total cost for the expected production volume. Okay, so let's say that, okay, you have three locations, okay, and Assen, Brussels, and then Lisbon, okay, and we say that the product can sell, $120 per piece, and then we expect it to be selling 2,000 units. And then we have three locations that identified. Now, of course, in this table, I easily give you those numbers, right? If you are researching on those three locations, probably you have to estimate the fixed cost and the variable cost, right? So with a fixed cost of $30,000 and a variable cost of $75, Assen's total production cost is 30,000 plus 75 multiplied by the number of units we expected to sell. Here in this case is 2,000 units. So we have the total cost that calculated there. Now, of course, once you've done these kind of calculation, it's very easy to pick. Okay, in the table listed here, which one has the lowest total cost? Brussels, with a fixed cost of 60,000 and a variable cost is $45 per piece. Your total cost is $150,000. Now, but in reality, we don't know how many units exactly we're going to sell, because demand is unpredictable, right? And then we wish this 2,000 to be more, and it could be less. So it will be better to understand if the volume, the production volume or the demand volume, right? Here we equal these two, right? If that changes, how does that change the overall total cost change? Now, and what will be the best location given all those, production volumes, right? So we actually can draw three lines here. These are the total cost line. The line with the function for Assen's total cost line is y Assen equals to 30,000 plus 75 multiplied by x, and x is the volume, right? And then we have the production line for Brussels and then for Lisbon. When you plot these lines, right, and then the starting point is the 30,000, and then this is the slope, okay, 75. So this is based on these three different cost structure, we can have these three different lines. Now, apparently, so what we see is that these lines has a crossover point, right? For the volume lower than 1,000, which location offers the best option? When we say best option is the lowest total cost, right? So apparently that's Assen. Okay, when the volume is between 1,000 to 2,500, which one is the best option? Brussels. So previously when we say that our demand is 2,000 units, then Brussels win in that case, right? So when the demand is production volume, right, is higher than 2,500, which location is the best? Lisbon, right? Because Lisbon, the red line, right? So this is basically the cost volume analysis. Now, this provides a mechanism for us to evaluate location choice based on the cost structure and then the production volume. Okay. So you can, basically calculate the crossover point and to figure out this, the critical units that you have to meet to pick the location. Okay. That's it. Okay.